but when you inject THC, you increase 14,000%. Another very interesting thing that again was something that I contributed with Pierre Piazza, but this is his discovery, is that there is a neurosteroid, a steroid that is produced in the brain that is called pregnenolone.
Pregnenolone, yeah.
Pregnenolone, that is a natural signal-specific inhibitor of CB1 receptor.
This is important because most people don't know this about pregnenolone. So for those that don't know anything about pregnenolone, this is what Giovanni's talking about right now. Is it's also got a signaling function. It's an inhibitor, essentially, of the CB1 receptor.
Actually, the story is interesting. It's funny because it was before I was coming here to Bordeaux, and Pierre, who was the director of the institute already, he had working on drug addiction. He had this idea that maybe steroids are important for drug addiction. So, and then I was going to come here. I was in Germany at the time, and he called me and he said, look, I did the experiment. The first experiment is to take all the drugs of abuse, THC, cocaine, morphine, heroin, and inject rats and measure in the brain this neurosteroids. And he told me, look, when we inject cocaine, we have some changes of 20%, 100% increase or decrease a little bit, but things that normally you would say, oh, this is fantastic, this is a great result. But when you inject THC, you increase 14,000%.
Pregnenolone goes up a lot after
14
THC.
times. Yeah. 14 times pregnenolone.
Which is huge.
Which is huge. It is really actually an endocrine increase. And so we were, when I came here, I sent him some mice because we had to check if it was CB1 dependent. They didn't have anything, any tool for CB1. I had the CB1 knockout. So yes, it was CB1 dependent. So the injection of THC activates CB1, which at low doses doesn't do anything. When you increase the dose, boom, you have this increase of pregnenolone.
So pregnenolone is being synthesized in neurons, presumably from mitochondria, in response to CB1 receptor activation.
Yes, presumably in neurons.
But it's a huge effect.
It's a huge effect, but then the problem started for us, particularly for Pierre, who was leading the project, and to say why. So what is going on? What is this pregnenolone doing? I mean, when we, at some point, once I remember discussing, Pierre said, and if it was the contrary, that it is inhibiting CB1. And when we realized this, we said, wow, this is a natural inhibitor. So now we know where is the binding site of pregnenolone, which is completely different from the binding site of endocannabinoids or cannabinoids. And this is the reason, for example, why pregnenolone in reality cannot be used as a drug. Because pregnenolone first is very badly absorbed, because the first idea was, I mean, we have something that can block the effect of THC.
Yeah, the negative effects, apparently.
Mostly the negative effects. And so you cannot use it as a drug because it is very badly absorbed. And then, of course, it's still a precursor of all steroids. If you take a lot of pregnenolone, then maybe you get too many estrogens. Maybe
it's poorly absorbed, but also probably it's highly sensitive to the dose.
So it is you are playing with fire because you don't know what happens. Okay. Yeah. So the idea, there was a company that was made to do that is called Elis Pharma, and the idea was to modify pregnenolone in a way to impede the modifications. The enzymatic transformation into other steroids. And these, for some compounds, improved the absorption also. So basically now there are compounds that are in clinical trials
I see. It's essentially a modified pregnenolone that's more easily absorbed, but also can't be used to create other steroid hormones.
Exactly, cannot be used to exactly. So this is an interesting example. I say always of pharmaceutical research that is driven by research. For neurological disorders, we have something. For neuropsychiatric disorders, there is almost nothing that came to research, from the research to the clinics. All what we use, antidepressants, blah, 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 they were found 50 years ago by chance. And having this thing that is coming directly from the molecular mechanism to the use to this to stimulate the safety system of the brain against excessive cannabinoid activation, it's pretty much exciting at the moment.